energy will be question number 5. Question number 5. Question number 8. So question number 8 and question here. Question number 8, question number 5, and question number 7 are related to this problem. Actually, yes, 5, 7, 8 are related to that problem. $12 also related to that problem. No, 12 is elastic collision. That's not inelastic. But 13 is in 2 dimensions, but it will be related to this problem as well. Okay, so any time that you see change in kinetic energy, energy lost, find the total energy of the system, is related to that problem. For example, let's say that they want question number 5. In question number 5, they ask, an 8 kilogram object moving 4 meters per second in the positive x direction has a one-dimensional collision with a 2 kilogram object moving at 3 meters per second in the opposite direction. The question, the final velocity of the 8 kilogram object is 2 meters per second in the positive x direction. The question, what is the total kinetic energy of the 2 mass system after the collision? So they want what is the total kinetic energy after the collision. So if we have 2 objects, the total kinetic energy after the collision is this plus this. Just after, which is the final. 1/2 mv1 squared plus 1/2 mv2 squared. When we set it up that problem, we can see that we have m1 and m2. Both masses, in this case, are 8 kilograms. They are given the velocity 1. How much is the velocity 1? u1. In problem 5, how much is u1? 4 meters per second, positive, right? How much is u2? -3 meters per second. It's a vector in the opposite direction. It's a vector. And then I gave last week. Okay, so what do you need to find? So if you have n1, which is equal to n2, which is 8, you have u1 positive what? How much is u1? 4. Positive 4. How much is u2?
2.
Negative?
Oh, u2, sorry, that's -3.
That's it?
Yeah.
They don't give anything else? Or they give the velocity of the first object after the collision? How much is B? B1. 2 meters per second, positive or negative? Positive 2 meters per second. So if you want to find the kinetic energy total, what do you need? What is kinetic energy total of that system? What will be? What is the kinetic energy total of that system? What will be the formula? Kinetic energy. 1/2 n1 v1 squared plus 1/2 n2 v2 squared. That is the kinetic energy final. They didn't ask for the energy lost. They asked for the kinetic energy final. So if I ask for the kinetic energy final, you just need 1/2 n1 v1 squared plus 1/2 n2 v2 squared. What you don't have? We don't have v2. How can we find it? And the idea here is always to work with two equations. Since this is elastic or inelastic? They didn't say, but we can prove that it's inelastic quickly. So if the energy, it doesn't conserve, but it doesn't matter. The momentum, if it's elastic or inelastic, have to conserve. Right? Since elastic or inelastic in both momentum conserve, what will be, or how can I find the final velocity? Using what?
Sorry. Why is mass 2 8?
Hmm?
Why is the second mass 8 kilograms?
Is that 8 there?
Yes, it has a collision with a 2 kilogram.
2 kilograms, okay, sorry. This is 8, and this is 2.
Correct.
Okay, thank you. Okay, this is what we have. My question is, how can I find B2? How can I find B2? Look at the equation in the board. Look at the theory of collision or linear momentum. What do you think that, how can I find B2? What can I use? Because in order to find the kinetic energy, I need to find B2. Are we fine with that? That we have to find B2? How can I find B2? The law of what? Of conservation of linear momentum. Do you have N1? Do you have U1? Do you have N2? U2? N1? B1? M2? Can you find B2? Yes. So you have to work here in this chapter with the concept that we learned from energy last week, or the previous week, and law of conservation of linear momentum. Anytime you see collision, linear momentum, conservation, Pi is equal to Pi, and you set it up that way. If you find the P that you need, or anything you need, then you can find the energy or whatever you want. The energy loss, energy. This is the key in this chapter. Okay, so in that question, you have to use linear momentum to find V2. Once we find V2, we can find the kinetic energy total, which is this part. If I ask for the loss in kinetic energy, what you have to do? This. The whole thing. If I ask what is the fractional loss, what is the meaning of fractional loss? Fractional loss. So what is the loss? This. Fraction out of what? Usually you take the out of what, the fraction? If it's fractional loss, out of the total, at what time? Beginning or end? Then if it's a fractional loss, is at the beginning. It's like the fractional loss.